In this video, I'm going to give a very short introduction to R, the programming language R, which is just the letter R. It's very powerful, free to use, and it's a programming language, which means you can do a lot with it. Like it's very flexible. There are a lot of analysis you can do, but you can also visualize your data in different ways you can do otherwise, or look at your data in different ways, or just use it as a calculator as well. I use it pretty much every day for my work. I also make my slides in it, and it's extremely powerful to use for statistical analysis. Now, the reason why we don't use it in the course as main method is because it does take some time to learn, while JASP is a nice point and click interface. But actually, JASP just uses R in the background. JASP just a graphical interface around R. You don't have to learn R, but if you want to learn it, I just want to give you some starting points to pick it up. Do expect that it will take some time, but I do think it's worth it to really try to put the effort in and try to learn R. It is a useful skill set to have, also outside of academia, for example, jobs in data science or other things. Now to install R, we actually have to install two programs. We go to this website here. We scroll down, this is RStudio, and it says two buttons here. We first have to install R, then we have to install RStudio. We click this button here, and then you can just follow the steps here to install it. So in this case, I have a Macintosh. Depends on what system you have. You can either install this one or this one, and you just install the software. Then you also install RStudio. You click it, and then you see it already starts downloading. R is a programming language. You can basically see it as being on your computer terminal. And RStudio is a graphical interface around the programming language, but not graphical in the sense as JASP, it's really like point and click. It still requires you to program, but it just makes the programming a bit nicer and easier to do. So that's why I always use RStudio. So if you install R, you actually get some different program on your computer, which is another older graphical interface around R. I don't use that. I don't think anyone uses that still. But you get it, so you don't want to click that. You want to install RStudio and then use R from inside RStudio. So let's take a look. So this is RStudio. If you open it, but for you it will actually look a little bit different. That's why, because I changed the layout a little bit. Go to Tools, Global Options, Pane Layout. And here you want to set this like this. Normally, I think here's the source, here's the console. So these are the four panels that we have. We only see three now, but the fourth one will appear later. The reason why I set it like this is because this source panel and this console panel are the main ones we use. And we want to use the horizontal space for that. So this is just an easier way to use it. Just make sure you have it set like this. And then we can say apply, okay. And then R will look like this. Now this thing here, that is actually R. I can type commands here, like 1 + 1, and press enter, and then R will understand it and will give me a result. I can do some mathematical formula here, like 2 × 5, for example, things like that. And this is actually R, but we actually won't use this. We're going to use something else. The reason is because we want to store commands and save them and reuse them later. So maybe I made a mistake here, I want to change that to 1 + 3, or just want to know what I did. So it's easier to work in something we call an R script. We write a command there, then we send it to the console. To open that, we go to File, New File, R script. And this opens what we call a plain text file. It's a plain text file. I'll just drag this down. We don't need this panel. It's a plain text file, meaning I can type things. Hello. And it doesn't have any formatting or fonts or boldface or things like that, which you don't need for programming. I want to save this file. I go to File, Save As, and then I can find the location for it. For example, this folder here. I call it something, R script, or something else, whatever you want. The extension has to be .r. Now the folder that I use for this is the same folder that I use to store my data, and that is quite important. So here I have a .csv file. It's the file that we used in the tutorials, which has the data. I save my script in the same folder. It will make things easier. Do save, and now I save my script. See here it's black. If I type something, it's not saved. Then I can press the save button or just do Command S or Control S. And I do this very often because you don't want to lose your commands. Now here I can type 1 plus 1, for example. I can select it and I can say run. And then you see it's sent here to this panel here, and I get the result, which is nice. The nice thing is that I can now keep track of this. And I can see what I did. I select it, I can press Command Enter, and then I run it. Or you can press this run button here, but Command Enter is usually a bit easier. Now here I can actually do quite advanced things. So let's say we want a average from 5 values. Let's say we see the values 4 plus 7 plus 3 plus 4 plus 9. I can type, for example, this. Well, I don't have to type the brackets. I can just do this. It gives me 27. If I do the brackets and then say divide by 1, 2, 3, 4, 5, select, then it will just run that mathematical command. 4 plus 7 plus 3 plus 4 plus 9 divided by 5. That is already much easier than typing this in a calculator, right? So I actually, anything I want to calculate, I use R. I boot up R and I write the command here and I calculate it. For things like sums of squares or the means or the variances, you can also use Excel or Google Sheets. And I uploaded an example of that on the conference discussion board. But yeah, R is also really good at that. Now, a nice thing about R is that I can also save commands. So I could say, for example, I have this one, or I can say save objects. And I can say I want to store this into an object. And when I do that, you see it's no longer printed. But now I can ask R, what is this object? And it is 1, which is nice. Because now we can use this. We can say object plus 1, for example, equals 2. So how can I use this? For example, I can say the sum score, and you can use any name here. It's case sensitive, so it matters if you have capital letters or not. So I can say sum score equals this. I send it to the R command. Then let's ask R, okay, what is the sum score? 27. And now I can ask R, okay, what's the sum score divided by 5? 5.4. So it allows us to do our calculations in certain steps. Now this code here becomes messy quite quick, right? It's already hard to see now what's happening. So a nice thing that we can do in R is write a comment. I can write with a hashtag sign, you see it becomes green. And then I can say here is a comment. I can type anything I want because R does not evaluate it. Basically it stops evaluating when it sees this sign. Why is this useful? Well, I can write, for example, here I compute a sum score. Here I divide by 5. And now print the result. So now I have what we would call an R script with multiple lines, and I can actually select all of them and press run or press command enter to run them all. And you see now it first made a sum score, then it divided by 5, and then it printed the result. And that's a really nice thing to do. Right, so there's a lot to say about this. There's a lot to say about the object types. There can be numbers, there can be strings, there can be true or false, things like that. We can store data, things like that. I don't want to make this video too complicated. I just want to make it introductory. So I want to show how you can do, for example, a t-test and load data. But yeah, to really understand what's happening here, I recommend that you read the chapter that I upload. And I will also upload some other materials that you can use for self-studying R as well. Now, let's try to do a t-test in R. So we have the data from our tutorial, this file, and I want to load this into R. Now I saved my R script in the same folder as the file, and that is quite important. I go to R, let's delete all these things here. And let's just press enter a few times here to get a nice clean environment. The first thing I need to do is tell R where can I look for data. To do that, I go to Session, Set Working Directory, to Source File Location. You see it runs some command here, and basically what it does is it tells R, okay, if I'm going to try to read data, look in this folder. Next, we need to read the data into R. Now there are many commands for that. And for example, you could do file import dataset. And here there are some tips that you can use from SPSS, for example. The one command that I will use is read.csv. And type in brackets the name of the file, in this case this one. I select this and I run the command, and you see that it did something. Now this is not always the command that will work. It depends on how your data is structured. In this case, the data was structured as a CSV file, which stands for comma separated values. And in that case, this command can work. But there might be some arguments that we need to set. And one thing we can do is look at the help file, the read.csv file. And this says actually another function called read.table, and read.csv is basically a variant around that. So this tells us what arguments we can use. So for example, maybe our file stores values separated by a semicolon, not a column, which is quite common. In that case, we would have had to use sep equals and then specify that it would be a semicolon. Now again, if you ever, this can take some time because it really depends on the type of data that you have. If you have a data set that you cannot load it in R, then feel free to also write me on Canvas or add it to the discussion board, and we can figure out the command that you need together. Now let's look at the data. You can type view data, select, command, enter. And this gives me a nice spreadsheet. Now you can see I cannot change values here. That's not how R works, but it does allow me to look at the data in a nice way. So I have here header, color, these numbers, and the sum score. And this is the data that we had already in the second week from the first week experiment. Now let's say I want to do a t-test. I want to see if cute hamsters or no header makes a difference. Right, so it's a bit simpler. We don't have the equations here. So let's see if that makes a difference. So let's do a t-test. right? We can write a command, t.test. And that's the thing about R, you need to know all these commands, right? So there's no menu button here. These are, yeah, there are a few, but this is not really giving you any commands or anything like Jazz does. But there's not like a t-test button here we can press. So you kind of need to remember that this command is called t.test. There are lots of like R overview or cheat sheets for that, or websites that help you with that, or you can Google. There's a big community on R, so if you just Google t-test in R, you'll get this command. Again, that's the main thing you need to remember what command to use. When I type a command, I follow it by brackets, then whatever is in these brackets are arguments to this command, or a function in R. And if I want to see how I should use a function, I can do question mark, and then get an explanation on how to use it. In this case, I want to do the t-test between the columns header, and I want to actually compare cute hamsters and no header on the interest. Let's do that. Header tilde, other way around. Interest tilde header, data equals data. And you see, I get a nice thing. Now this is an argument, this data here is this object. If I would have called this object different, like df or dot or whatever, I had to change this object here. And this tells me this is the dependent variable or the outcome variable, this is the independent variable or the predictor. This tilde means this is predicted by whatever's on the right here. And we see a nice result here. We see a Wells tooth sample t-test. Well, that's weird, right? Degrees of freedom is 567.25. That's weird. Why is that? Well, we can look in the help file. And we see here that there's an argument called var equal. And it has a default value of false. Means that we, by default, assume that variances are not equal. Actually, we always assume that they are equal. Pretty much always. So we just say var dot equal equals true. Run the command. And now we get the t-test. Degrees of freedom is 61, which is 63 minus 2. We get a t-value, and we get a p-value. In this case, there is no significant effect. And this tells us a lot of information about our test. We could have done a one-sided test. There's an argument for that as well. In this case, actually, I did have a prior hypothesis here. So we could say alternative is, for example, greater or less, depending on your hypothesis. Let's not do that. Let's do the two-sided test. Here we have the two-sided test, and we get the t-value, degrees of freedom, and the p-value. Now I can also do a correlation test. I can write core.test. And this one actually works a little bit different. I have to say data, then the $sign, which means get a column from this data. And then say, for example, good grade, which gives me one column from the data. So this gives me these values, these ones. Then I want to compare that to data. And then, for example, if you don't get this menu, you can press tab to get it. Let's say interest. Is there a correlation between interested in the course and expecting that you get a good grade? I run this command and I get a correlation test. It has a t-value here, degrees of freedom, and an associated p-value. In this case, the correlation is super significant. these values are very highly correlated with each other. We can also make a nice plot for that. Actually, it's the same command. We just write plot. Oh. You get a nice scatter plot here. Now finally, we can do the linear model. In the linear model, there's actually a very important command in R. That's the command that you will probably actually use if you do linear modeling. Linear modeling includes multiple regression, simple regression, t-test correlation, and ANOVA, really. So we could write ln, and let's say now we want to predict if you think you will get a good grade from your interest in the course. And I can write it like this. Predict good grade from the interest in the course and use data. I can select, command enter, and I get some warnings, but those are due to the plot. This thing does work. And now I can see, okay, results. Look at the results. This is not very interesting. So what I can do is, okay, summary, results. And now I get some interesting output. I get output from linear model. I get the estimate for the intercept, the estimate for the slope, and the significance of the slope. So this slope has a t-test of 11.07, a t-value, with a very significant result. We also had t equals 11.007 in the correlation. It's the same thing, the exact same value, because we're actually testing the same thing. Right? We also get our residual standard error with the degrees of freedom in this model. In this case 61, because we have, I'll type that, 63 data points, and we have two parameters that leads to a residual degrees of freedom of 61. We get the R squared, we get the adjusted R squared, and we get the F statistic, which I'll talk about in week 5 in more detail. But in this case, we see that the p-value is again exactly the same. That this F statistic is telling me that the regression model is explaining variance, but the regression model in this case is only this one parameter, this one slope, which is the same as the correlation. We could do also a t-test using a linear model. So let's say I just copy this command here, but put it in LM, and look at the results. So now we get a linear model. Oh, I had to write the correct command here because I saved as rest2. And now we get t is 1.23, p is 0.221. What do we get when we run the t-test? T is 1.23, well minus, but that doesn't really matter. P is 0.221. The exact same result. Now finally, if you want to run a multiple linear regression, I can add predictors here. So I can say plus, and let's say what the names are. Let's actually look at the data. We had excited as well. Let's call this 3. I run this command, and let's look at the summary. And now I get interesting output. I get the coefficients or interest and excited, their associated p-values, and I get the F value, or does the model in total, is the model a good predictive model? Now, this p-value is no longer the same as these two, because it's basically a p-value of if both these predictors are good. And we'll learn more about that later in the course as well. Okay, so that's a very brief introduction to R. Now again, it will take quite some time to learn R, so don't feel discouraged if this is a lot and you don't want to learn it or you think it's hard. I will upload this R script so you can play around with it as well. And yeah, I'll try to upload some resources. And if you have any questions about R, feel free to contact me as well. Now, if you don't want to learn R, it's not required for this course, but I can recommend that you at least try it and see how it works. Alright, that's it for this video.